All right, biology. Unit 11 has to do with the cycles of non-living matter that goes on in ecosystems. If you remember last unit, sorry, I'm a little hoarse. Last unit we talked about ecosystems, and we really looked at the living components. But an ecosystem is made up of both the living and the non-living components. When we looked at the living, it was food webs and primary consumers, secondary, tertiary consumers, all that kind of stuff. But for this unit, at least the first little part here, we're going to talk about how matter, non-living stuff, flows in and out of an ecosystem. They do so in a cycle, meaning that they come in and then they go out of the ecosystem, but eventually they'll come back into it. Some of it happens very quickly. Some of it can take even hundreds of thousands of years. An important, super important law in science, and you see the stars right there, the law of conservation of matter. Okay, matter is all stuff, right? Matter makes up all things. And the law of conservation of matter tells us that matter is not created nor destroyed. So we can't just make something out of thin air. And even when we destroy something, if we burn it, we explode it, we melt it, we do all this different stuff, the amount of matter that makes up something really isn't gone. Okay, matter can only be transferred into different forms, right? So everything we're looking at today, the water cycle or the nitrogen cycle, all these different things, they may change forms, especially like water, from a solid like ice to liquid water to water vapor, which is a gas. It may change all these forms, but the amount of matter that's found in that water stays the same because we can't create or destroy anything, right? So let's see what we got going on. The hydrologic cycle, more commonly known as the water cycle, is one that you've probably learned about in elementary school somewhere. It's very popular in elementary type science because it's so easy to observe. This is the pathway, this cycle, the circular pathway of water on Earth. So if we follow some water, say just a drop of water, we may see it take on different forms as it flows in and out of different ecosystems or different environments. So let's take a look at it here. I've got several pictures, and on your notes I also put pictures like this to kind of show you how it flows, just as a good visualization. So we got the hydrologic cycle. It's a circular pathway of water. Water in the atmosphere, so the surrounding layers of, around Earth in the air, it falls to the ground, right? As it's up there, it's water vapor. It's a gas. It's what the sky is made out of. It's what clouds have in them, right? It's water vapor, but it falls to the ground, and when it does that, it's known as precipitation. And precipitation can take on several different forms, and sometimes a mix of these things. Rain is the most obvious one. We also have snow, hail, sleet, fog. Dense fog can even be considered precipitation. This is when water falls to the ground, right? Once it hits the ground, it doesn't just go away. Now it may, through the form of evaporation, we're about to talk about at the bottom of the page, but most of the time it flows to somewhere else, right? If you've ever been on a hillside, or maybe you live on a hillside, and you've seen during the rain, all of it flowing downhill. It's all going to, remember how water likes to stick to itself? That was one thing we learned about way back when. Cohesion is what's that called. This water is going to flow to large bodies of water, right? So water flows down into streams, streams into rivers, rivers into lakes. The lakes may flow through other rivers down to the ocean, okay? Water always collects. Another thing that water does is it seeps into the ground, and this is called seepage, right? So if you've ever seen a puddle and it kind of looks like it's going downward, it's disappearing, it's not. It's just seeping into the ground. So we call it seepage as it flows through the ground. Now some water, liquid water that falls to the ground, becomes vapor again. How does it do that? Through evaporation. Okay? Evaporation is when liquid water hits a certain temperature that it turns into a gas, right? So we're looking back real quick. We've got precipitation falling to the ground. It's running off into these different bodies. Here's an ocean, here's a lake, all this different stuff. It also sometimes may seep into the ground, and that's where you get this term groundwater. If you have a well at home, or you know somebody that gets their water not from like city pipes, but from a well, they are tapping into that groundwater. Okay? They're tapping into it. So once water's on the face of the earth, it can condense. And that's what it's called. It evaporates. It's not condense, excuse me. It evaporates up into water vapor. You might have saw right next to what I was pointing at. When water evaporates from plants, we call it transpiration. Okay, transpiration is what these plants do. If you've ever seen a plant that looks like it's almost sweating with little water droplets, sometimes those water droplets aren't just left over from the last rain. It's actually where the water is being pulled out because of temperatures out of the plant, and then they evaporate from there. That's transpiration. So once water vapor goes up in through evaporation or transpiration, they go back into the atmosphere here. It goes through something called condensation. And this is where the cycle's going through, right? We started out with water vapor that became precipitation, came down. It made its way on Earth for a while. Then it evaporated. It goes back up. It condenses. It cools. And it becomes liquid water again through the process of condensation. So the cycle, then it just keeps going on and on and on. This is cool to me because you may be drinking water that Julius Caesar once drunk. If you really think about it, of course, it's gone through his urinary system and out through many oceans and different places since then, but it may be the same. Sorry, had to reset there. All right, so the cycle repeats. Next, we've got what we call biogeochemical cycles, right? And that's just a fancy word for things other than the hydrologic cycle. Many elements that are essential for life, right, cycle through ecosystems as well. We don't really notice it because it happens kind of out of our view, but these things happen. One is the oxygen cycle. And we've already learned a little bit about the oxygen cycle earlier this year with things like photosynthesis and respiration, cellular respiration. This is the cycle of those two events. So look at this cow. Moo. Trees or plants, they create oxygen. It is a waste product of photosynthesis. You might remember that. So oxygen enters into the atmosphere, it's just hanging out. And then animals and plants, they breathe in the oxygen. And that oxygen, if you hopefully remember, is a reactant that's required for cellular respiration. It's what gives this cow and all living animals the energy, ATP, to continue normal life. But they breathe out carbon dioxide. Carbon dioxide is a waste product that comes from cellular respiration. Thankfully, this carbon dioxide goes in the atmosphere and is not wasted. Instead, plants will use that carbon dioxide as a reactant for photosynthesis. One of the largest producer of oxygen in the world is actually algae, found in the ocean. So many people dwell on the rainforest and trees and do this. Don't cut these down. Don't do that. That's great. But we can actually breathe without any trees because of algae in the ocean creating oxygen that goes up into the atmosphere and pretty much covers the entire Earth. Here is a breakdown that I just talked about in the picture itself. Most organisms are going to use oxygen for cellular respiration. So we got to have oxygen. Right? The cycle is vital to life on Earth. It's produced by photosynthesis in producers like plants and algae. Living organisms take in the oxygen, and then they release carbon dioxide, just like our friend the cow a minute ago. In turn, those producers are going to take in carbon dioxide to use during photosynthesis.